One form of the ideal gas law is that the pressure times the molar mass is equal to rho, the density, times the gas constant times the temperature. And from a fluid in equilibrium, we have the relation that the change in pressure over the change in height equals the negative product of rho g. So if we solve the first equation for rho, so if we take this equation, we can say that rho equals Pm over RT, and we plug that into the second equation. We get that dP over dy equals minus Pm over RT times G. And now, if you've taken differential equations, you know this is separable, but if you haven't, notice that we can divide both sides. Let's first multiply both sides by dy, and we get minus Pm over RT times G dy. And then what we're going to do is we're going to divide both sides by P, so we get dP over P equals minus mg over RT dy. And now if I integrate both sides, notice that m, the molar mass, g, acceleration due to gravity, r, and t are all constant at a specific y value, so these can all come out of the integral sign. And if we do that, we get that this is the same as minus mg over RT integral of dy. And if we integrate this, this is going to be from some pressure point P1 to some pressure point P2, and this will be from some height Y1 to some height Y2. As we know, the pressure changes with height. So, and from your calculus, if you remember, this is going to be the natural log of P evaluated between P1 and P2 is going to equal, this integral gives us minus mg over RT times y evaluated between Y1 and Y2. And now if we plug in the integral limits, we get natural log of P1 over minus natural log of P2 minus natural log of P1 equals minus mg over RT Y2 minus Y1. And if you remember from your algebra, when we subtract natural logs, that's the same as dividing their arguments. So the next line should be natural log of P2 over P1 equals minus mg over RT times Y1 minus Y2. And now what we can say is take the exponential on both sides, which means that P2 over P1 equals e raised to the minus mg times Y2 minus Y1 over RT. And finally we can say that P2 equals P1 e to the minus mg Y2 minus Y1 over RT. And now notice that the y2 minus y1 is the height difference. So we can always take y1 to be some reference point 0. And now we can try and evaluate this. So let's try and find what mg y2 minus y1 over RT equals. The molar mass of air, 28.8 times 10 to the minus 3 kilograms per mole times 9.8 meters per second squared times the height difference is 88.48 meters all over R, which is 8.314 joule per mole Kelvin, and the temperature is 273.15 kelvins, and that gives us a 1.1 value. And now we can say that P then, P2 equals P1, which is atmospheric pressure, times E raised to the negative 1.10, and that will give us a value of 0.337 times 10 to the 5th Pascal, which is approximately 0.33 ATM.